Finally, we're going to access data from the National Hydrography Data. That's going to be polygons for lakes, rivers, and ponds, and then lines for small streams. Access these data through the Geospatial Data Gateway at the nrcs.usda.gov. Click once, then hit the big green button. Go ahead and select the state. We are in the great and good state of Maine. And then we can select the county. Submit selected counties. We have a whole variety of data sets here, but let's go ahead and find our National Hydrography Dataset. There it is. So check that on and continue. To tell it what format, and I'm going to use Esri shapefile, and then the projection, which is going to be UTM Zone 19 North. From there, continue, and provide your email. Continue. A duplicate order is already available. Thank you very much. So I've already done that, but when you do that, it's going to give you a notification saying we're preparing this information for you, and it'll show up in your email 5-10 minutes down the road. Now, when I did this the first time, it bounced me back to number 2, what? And it wanted me to select the NHD dataset again, but the issue was that it wanted to send it for the whole state rather than clipping down just to Aroostook County. So if that happens, just go ahead and recheck the box for the NHD dataset, go through the how, the who, and review, and then place order. The email you get looks like this. You have to then go down to this link, download the .zip file, and extract it just like the others. Once you've extracted that, in the Browser tab, you'll have 1, 2, 3, 4, 5, 6 shapefiles. At the moment, I want to work with 3 of them. Let's start with KAR_A. Polygons for the larger rivers. Not perfect, but very, very good. See how we have a little bit of shoreline not covered there. KWB area, waterbodies. That's all of your lakes and ponds, including the name. KST_L, lines for streams. Let's go back to our Layers tab and give these a reasonable symbology. Let's make that a blue line. Rivers, blue. A lighter blue stands out well for these lines, I find. We'll give that a little bit thicker line. Okay. And then we have our water bodies. I'm going to give that a darker blue with a very dark blue outline. Okay. And for our larger rivers, I'm going to do something very similar. So let's go ahead and pick that one. And the stroke color, I'm going to make another dark shade of blue. If you want to make those distinguishable from one another, go ahead and do that. But for me, I like to look at them just about the same. Now let's show you how to do a 250-foot buffer on this feature. And we've got to use the right one here. So we have some water bodies there. We have our river there. And then we have this line that represents where that river is, but does not represent its banks. The regulatory distances pertain to the distance from the high water mark, not from the center line. So I'm going to select using this here. If you don't have this toolbar, it's under View, Toolbars, Shape Digitizing toolbar. So now I'm going to use the Select Features tool. Click, hold, drag a box, and you see how it's selected all of that. That's connected to that, and so is that. So that's the one continuous feature that we've selected. So we're going to buffer on that and accept that maybe that one doesn't actually get a 250-foot buffer. We could modify that feature, but for right now, let's just demonstrate how to do the buffer. Vector, Geoprocessing Tools, Buffer. Make sure the input layer is the one we want, the NHD 24KAR area, and then make sure we're in feet, enter in 250 feet for our distance, and run. It's going to create a temporary layer. If we decide we like that temporary layer, then we can decide to keep it, and we have to save it as a permanent file. So there's our 250-foot buffer. I'm going to change that simple fill to no brush, and then I'm going to make that a bright blue line. And instead of a solid line, I'm going to make that a dot line. Let's see how that looks. Barely visible. Double click, and let's make that line a bit thicker. A bit thicker, apply, there we go. Now I'm going to clear that selection, and there we go. So now we have the stream, its edges, and the buffer on those edges. So what the buffer tool has done is taken this edge and moved it out 250 feet, creating a new area here. Smaller streams get a 75-foot buffer. And if you have a very precise streams layer, you can actually use that buffer in operational layout. Never without checking to make sure it is where you think it is, but if you have 1 meter resolution LiDAR data, you can get a very precise location of the stream. But this is not that. You can see here, there's the stream, there's the line representing the stream. LiDAR very often hits that right on, but this old line from a topo map does not. Let's for a moment pretend this was accurately located. We can do the same thing, and we have to use our selection tool, and we have to click on the layer that we want to select from. Click, hold, and drag. There it is. Scrolling out, we've selected just that stream. And now I see why it took so long to buffer these rivers. I forgot to check the box saying work on only the selected features, so let's do that this time. Vector, Geoprocessing Tools, Buffer. Ensure that we have the right one selected, NHD 24KST line, and work on the selected features only. And the distance is in feet, and the distance is 75. 75 feet from what? From the edge of the stream bank, from the normal high water mark. How wide is the stream exactly? We don't know. It's probably not wider than 10 feet for a small stream like that. If we zoom way in on this, we can measure the part of it we can see using our measuring tool, distance in feet. Start at one side, double click on the other. That looks like we got that pretty well 7 feet. Let's go ahead and give it a bit of a safety margin there and just make that an 85-foot buffer. And again, I'm going to create a temporary layer. I could save this anywhere I want. I just click there, save to file, give it a name and a location. Run. Done. And just like the rivers, I can give this a simple fill with no brush, and then make our stream buffer a nice dotted line, 0.66 millimeters thick. Scroll out, there's our buffer on that stream. Remember, this in particular is for demonstration only. This layout with LiDAR data is practical. You do still have to check to make sure the stream is where the LiDAR dataset calculates it to be, and that the width is what you believe it to be as well. But if this line is where the stream is, and you know the width, then you can provide the operator with a GIS or a Avenza-enabled PDF map showing where the buffer begins. Now if we go back and look at our land use plan and commission zones, you'll notice that our 250-foot buffer corresponds exactly to theirs, with a few minor zigs and zags. Where this one is beyond that 250-foot buffer, and that is the P-FW, Fish and Wildlife. Different zoning requirements mentioned earlier. So in Maine, the regulations for a 75-foot buffer around small streams start when the stream drains 300 acres or more. I have another data set derived from the 10-meter resolution elevation model that calculates exactly where those begin. We'll talk about that later and how to calculate it. But for now, I'll just say that they roughly correspond with the lengths of these streams here. But it's still better to have the actual calculated value, and even better when you calculate that value from a LiDAR data set.